What do a Boeing, Netflix and doctors working behind a computer have in common? I hope it is not too far of a stretch to see that they all rely on software. What makes these systems work are lines of code. These lines can grow pretty large. How large? A Boeing 787 contains about 14 million lines of code. It has more lines of code than parts, and that is including nuts and bolts. Impressive, right? Still, bigger systems exist. Microsoft Office uses about 45 million lines of code, and Epic's medical record system requires an estimated 50 million lines. Still, bigger systems exist. Facebook runs on about 62 million lines of code, and modern cars can contain up to a dazzling 100 million lines. So, yes, our world runs on software. And it is complex, leading to all kinds of issues. I could give many examples of infamous software bugs that caused big trouble, but I've chosen to highlight one. In 1992, a new software system called LASCAT was introduced in London to automatically assign ambulances. Of course, the expectations were high, but soon after launch, the system failed. Ambulance dispatch broke down, and emergency calls piled up. As a result, ambulances failed to respond. Wait times rose to 11 hours, and the media even reported 20 to 30 possible deaths due to delayed response. What happened? A public investigation later revealed that 1. The system was not tested well. 2. The needs of ambulance staff were not understood. 3. Project goals kept changing throughout the project. And 4. The system launched too fast without a backup. Only years later did the London Ambulance Service recover with a new, well-tested system. This shows that building large software systems is hard and potentially dangerous. As I mentioned before, software is complex because software systems often contain millions of lines of code, which are hard to maintain. Additionally, software developers are not always experts in the application domain they are building for, and stakeholders typically use different languages and assumptions. And because there are so many components, people, deadlines, and regulations involved, project management becomes difficult. The result? Systems become slow, unreliable and difficult to maintain. Projects go over budget and deliver less value than expected. So, what do we need? We need software engineers that can manage the process of software development. Software engineering is the systematic development of software as a team across multiple versions. It is more than just writing code. Instead, it is a structured problem-solving activity focused on quality and maintainability. It consists of 2 mental processes: programming in the small, or coding, and programming in the large, which includes modeling, planning, and documenting. By analogy, programming in the large produces the construction drawing, while programming in the small produces the actual building. As in construction, it is crucial that the model and the final implementation match. Keeping the blueprint aligned with the code is one of the trickiest parts of software engineering. As you can imagine, this is why programming in the large benefits so much from a clear and effective modeling language. We will explore this further in the next video.